Okay, so this example is asking us, now I better write the question down so you know exactly what we're talking about here. But they want us to verify that the diagonals of the parallelogram, and these are the vertices, verify that they bisect each other. So we got to go through a couple definitions here. Verify the diagonals. Spelling that right? No, I'm not.
Sorry, I think
On
this when you're writing.
Verify the diagonals bisect each other. Okay. First of all, we'll put up a parallelogram quickly. Here's a parallelogram. The diagonals are referring to opposite points on the parallelogram, going from one corner to the other. To bisect something means to cut it in half perfectly. So at what point would they be hitting each other then? In the middle, which we know as the midpoint. Yes. So in order to verify this, I first of all need to find the equations of these two diagonals. Then I need to find the midpoints of them. And if the midpoints are the same, then we can prove that they bisect each other. So I'm going to get rid of what I have here. Whoops. That one. Okay. Let's get rid of these two. And let's actually plot these points. So the first point P is at -2 and 1, which will be right there. There's our point P. Point Q is at 3 and 3. Point R is at 4 and -1. And finally, point S is at -1, +3. I feel like I've done something wrong here.
You just have
Oh, sorry. -3. I knew something was off. There we go. So we're going to connect the dots to create a parallelogram. So they haven't told us to verify the parallelogram, which actually I think is important to do. So the very first thing we're going to do with this is we're going to actually verify that this is a parallelogram. And from our definitions of a parallelogram, that means two opposite sides have to be what? Parallel to each other. Okay? So I'm going to actually have to find the slopes of all four sides to verify this is a parallelogram. Okay? So the first point or the first line I'm going to be working with is line PQ I'm going to start with. Okay? So I want to deal with line PQ. PQ, which means I need the points P and Q. P was at -2, 1, and Q is at 3, 3. Okay? And now, because I'm verifying it's a parallelogram, I need to know I need to know their opposite sides are parallel to each other, which means I need to know the slope of these lines. So I need to find the slope of line PQ. So our formula we work with is y equals mx plus b. Okay? And I need to find the slope. The m is what's important here. Okay? So slope m is equal to y2 minus y1 divided by x2 minus x1. So let's give these points. Point P will be 1. And point 2 will be x2 and y2. We're going to plug in the coordinates. So y2 was 3. Subtract y1 is 1. Divided by x2 is 3. And x1 is negative 2. So subtract negative 2. This is going to give us our slope of line PQ. So m is equal to negative 2 over 5. So there's our slope. Okay, remember, I only need the slope. I don't need to find anything else yet about it to verify it's a parallelogram. Oh, yeah, you're right. It is positive 2. Thank you.
Goodness, sir.
Okay, next one. We need to verify the opposite side, which is point... I didn't put a letter in there. S. We need to verify SR is parallel to that. So in other words, I have to find the slope of SR. Again, SR, this line, we'll put our 2 coordinates down. S is negative 1, negative 3. R is 4 and negative 1. We need to find the slope again. We know that the M, we use the same formula. We're going to plug our values in. Now I need to give these an x1, x2. So I'll call S1, so it's x1, y1. R will be 2, x2, y2. Y2 is negative 1. Minus y1 is negative 3. Divided by x2 is 4. Subtract x1 is negative 1. Negative 1 subtract negative 3 is the same as negative 1 plus 3. And 4 subtract negative 1 is the same as 4 plus 1. So m is equal to 2 over 5. Slopes are the same, so we've now verified that PQ is parallel to RS. Okay? And remember, right now what we're doing is we haven't even started the question. We're only verifying that it's a parallelogram. The next thing we're going to do is point PS. We're going to find the slope of that and compare it to the slope of QR, making sure they're parallel to each other. So, we showed you how to do this using the formula for slope and getting the exact amounts. If you're able to read the graph, a quick thing you could do is go the rise over run from the 2 points. So we know we went in the negative direction, 1, and then up 1, 2, 3. So the slope of that would be 3 over negative 1. So again, we're finding the rise over run from these 2 points. So I need to go from here up to here. So first I deal with the run, which was in the negative direction 1. Then I went up 1, 2, well I went up 4 actually, 3, 4 points. Good thing I counted that again. Our rise was 4 and our run was negative 1. Then I go from the opposite side, the Q and the R. I went 1 in the positive direction, which is our run. And we went down 1, 2, 3, 4 units. Over 1, 1, 2, 3, 4. Down 4, so negative 4. So if you guys notice these slopes, remember the negative can be applied to the top or the bottom, are the same. We have negative 4 over 1 and negative 4 over 1. So we have verified that all of the sides are parallel to each other.
This makes some sense.
So,
What's that?
parallelogram, we've already verified. Now we're going to go back to our original question. Verify the diagonals bisect each other. So, our diagonals are actually S to Q and P to R. So we're going to write those coordinates down here. We have SQ, which is one of them. S is negative 1, negative 3. Q is 3 and 3. Is that right? SQ and PR. PR is our other diagonal. Line segment PR Point P is negative 2 and 1. R is 4 and negative 1. So we need to verify that these two diagonals bisect each other. So that means they need to cross exactly at their middles. So the only thing I really need to do is find the midpoints of both of these lines. Let's go make sense of this. So I need to find the midpoints of these two lines. And if they're the exact same, that means they're going to bisect each other. But if the coordinates of the midpoints differ at all, they don't bisect each other. They're not crossing exactly in the middle. Okay? So let's go back to our midpoint formula. Our midpoint formula, x2 plus x1 divided by 2, y2 plus y1 divided by 2. We use that formula twice. So we have our two formulas, and we need to put our points in. We're going to call S our first coordinate, so that'll be x1, y1. And we'll call 2 our second coordinate, x2, y2. Same idea over here. We'll call P our first coordinate, x1, y1. And R our second coordinate, so we have x2, y2. And then we're going to plug the points in. So we'll do this one in red. x2 is the number 3, plus x1 is negative 1, divided by 2, comma. This separates the points. y2 is 3, plus y1 is negative 3, divided by 2. Our other coordinate, actually we'll just keep going, we'll solve one at a time. So, our midpoint of the first one, 3 plus negative 1 gives us 2, divided by 2. And 3 plus negative 3 is 0, divided by 2. So the coordinate of this, 2 divided by 2 is 1. 0 divided by 2 is 0. Okay? So our other midpoint needs to be the same. We're going to plug in our formula. x2 is 4, and x1 is negative 2, so plus negative 2, divided by 2. y2 is negative 1, plus positive 1, divided by 2. We're going to equate this. 4 plus negative 2 is 2, divided by 2. Negative 1 plus 1 is 0, divided by 2. And lo and behold, our midpoints are at the exact same point. So this would be the verification that these two diagonals bisect each other.